All right, we're back again, and today we're going to start on Chapter 8, Section 6, which discusses solving equations with radicals. So today what we're going to focus on are these two first areas here, solving radical equations by using the power rule, and solving radical equations that require some additional steps. So those first two objectives are what we're going to focus on. Objective 1, again, solve radical equations by using the power rule. Hooray. The power rule for solving an equation with radicals is if both sides of an equation are raised to the same power, all solutions of the original equation are also solutions of the new equation. If you go back to what we originally discussed with the design of algebra, it's based upon balance. So here we have our balances. So we've said before, if I add the same amount to each side of the equal sign, I stay balanced. If I subtract, if I multiply, or if I divide, I still say stay balanced. Well, the same as if I raise to a power. Okay, and we'll use that caret top, that symbol we use when we do Socrative. So when we raise to a power, we are still the same power. We are still balanced on each side. All right, so there is some caution that has to be observed when we're doing this, and that's when the power rule is used to solve an equation. You have to check your solutions into the original equation. Any solutions that do not satisfy the original equation are called what they call extraneous solutions, and they've got to be discarded. Okay, so we've got to be aware of what's going on with that, and that's one of those parts that we're going to have to do a little bit of extra work at the end. So the first example we have here is the square root of 5x plus 1 equals 4. Well, to get rid of a square root, very simply, we square it, right? Square root of x times the square root of x is x. So if we square square each side of the equation, we still remain balanced. So we end up with 5x plus 1 equals 16. 5x equals 15, and therefore x equals 3. Now, as we've said, we've got to check this. So we plug it back in. So we get 5 times 3 plus 1, which is the square root of 16 equals 4, and we can see that's all true. So pretty basic approach here. And there's your original equation. The solution set is 3, and that's what the proper set notation down at the bottom of the screen there. So the steps involved. Step 1, we want to isolate the radical. We want to get it by itself. Make sure it's alone to one side of the equation. Then apply the power rule. So we raise both sides of the equation to a power that is the same as the index of the radical. And then we solve the resulting equation. If it still contains a radical, you repeat steps 1 and 2 again. And then you check all your proposed solutions in the original equation at the end. And if they come out, well, then that's your solution. Okay, so here we have the square root of 5x plus 3 plus 2 equals 0. So taking a look at this again, we want to first go back to the first thing, isolate the radical. So we're going to subtract 2 from each side. We get square root of 5x plus 3 equals negative 2. Now we're going to go and apply, we're going to stop right there because this has no solution because the square root of a real number must be a non-negative. So the solution set is an empty set. All right, now some additional steps that could be involved here. All right, so now we've got the square root of 5 minus x equals x plus 1. Now the radical is already alone on the left side of the equation, so that part's done. Step 2, square both sides. So I end up with the square root of 5x, square root of 5 minus x squared, I get 5 minus x. X plus 1 quantity squared is x squared plus 2x plus 1. I have now got a quadratic. So we want to get 0 on one side. So we're going to subtract 5 minus x from each side. We end up with 0 equals x squared plus 3x minus 4. We go back to our rules. What are the factors of negative 4 that add up to positive 3? Well, it's positive 4 and negative 1. So you end up with x plus 4 and x minus 1 equals 0. Set each equal to 0. X plus 4 equals 0, or x minus 1 equals 0. And you end up with x equal to negative 4 or x equal to 1. So now we've got to check each solution in the original equation. So 5 minus x equals x plus 1. So you put in negative 4. And we end up with the square root of 9 equals negative 3. Well, you cannot have that, so that's going to be 3 does not equal negative 3. Therefore, that's false. So now we go and do the first one. 5 minus x equals x plus 1. 5 minus 1 equals 1 plus 1. Square root of 4 equals 2. 2 equals 2. So this is true. So the solution is 1. The other solution, negative 4, is extraneous. Do not forget to do this step. Okay, over here we have the square root of 1 minus 2p minus p squared equals p plus 1. So again, the radical is alone on the left side already. So we can just go ahead and square both sides. And we're going to end up with 1 minus 2p minus p squared equals p squared plus 2p plus 1. So it's a quadratic, so we get 0 on one side, so we're going to add p squared and 2p to each side, and then subtract 1. We end up with 0 equals 2p squared plus 4p. So we end up with, factoring out, 2p. So we end up with 2p times the quantity p plus 2. So 2p equals 0, or p plus 2 equals 0. So p is equal to 0, or p is equal to negative 2. Now you've got to check. So let's do p equals 0 first. So you're going to take p out, put 0 in. So it becomes the square root of 1 equals 1. Well, and that's true, right? So that's all done. Over here we put in negative 2. So 1 minus 2 times negative 2 minus 10 negative 2 squared. We end up with the square root of 1 equals negative 1. That's not correct. That's false. So the solution set to the original equation is 0. All right, now we've got two radicals in the picture. Well, we want to get only one to each. We want to have them opposite each other. So when we square this, these are, we get rid of both, okay? We don't want them both on the same side. So we get the radical, one radical to the left, one radical to the right. We're going to square both sides. All right. So you end up with 2x plus 3 equals 1 minus 2 times the quantity x plus 1 plus x plus 1. So now you isolate that remaining radical, and we square both sides again. And we get x squared plus 2x plus 1 minus negative 2 quantity squared plus times, square root of x plus 1 quantity squared. And we end up with x squared plus 2x plus 1 equals 4 times the quantity x plus 1. Now we continue on by distributing. Then we subtract 4x plus 4 from each side to get a quadratic. We end up with x squared minus 2x minus 3 equals 0. So now we want to factor this out. The factors of negative 3 that add up to negative 2. So we end up with x minus 3 times quantity x plus 1. So x is negative 3. X minus 3 equals 0, or x plus 1 equals 0. So you end up with x is equal to 3, or x is equal to 1. Now we got to check. So you put it in. 2 times 3 plus 3, so the square root of that, plus the square root of 3 plus 1 equals 1. So 6 plus 3, square root of 6 plus 3 plus the square root of 4 equals 1. Square root of 9 plus square root of 4 equals 1. 3 plus 2 equals 1. That's false. Not good. So now we check negative 1. Plug it in. 2 times negative 1 plus 3, blah, 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 blah. Right? Plug it in. We get square root of 1 plus square root of 0 equals 1. And 1 does equal 1. That's true. So the solution set is negative 1. This is going to be the hardest part for some of you guys, is to go ahead and plug it back in to solve.
That's all, folks.
Please do your homework.